Okay, so in this video we're going to be looking at finding the length and midpoint of a line segment. So these are, we're going to develop some formulas here. A formula finding the length of a line segment, or the distance between 2 points, and a formula for finding the coordinates of the midpoint of 2 points. The thing to be wary of or mindful of, or certainly what I encourage my students, is that these formulas are quite ugly, and there's a lot of things going on in these formulas. I think we talked about this in an earlier video, but I really want to encourage you not to just feel as if you have to learn and execute a formula. Okay, I really want to encourage you to understand what the formula is doing, because then in that way, even if you don't remember the formula, it doesn't matter. You still can work out what the length of a line is, or what the distance between 2 points is, or what the coordinates of the midpoint is. So let's have a look at some examples. So we have a line segment joins 2 points, A with coordinates 4, 1 and B with coordinates 2, 5. Plot the line segment AB on the axis below, and then use Pythagoras' theorem to calculate the length of the line segment. Okay, so A has coordinates 4, 1, so that's A there. Okay, and B has coordinates 2, 5. Oh, sorry, I've made that. Sorry, 4, 1. Silly. It's a bit early. I'm not awake yet. 4, 1, so that's the point A, and 2, 5 is the point B. Let's put that up there. Okay, so plot the line segment. So a line segment is a line that joins 2 points. So just definitionally, a line goes on forever. Okay, on and on and on and on and on. A line segment is a part of that line that stops at 2 endpoints, and you should be able to mark those endpoints, which we have. So we've got A and B. Plot the line segment on the axis below, and then use Pythagoras' theorem to calculate the length of the line segment. Okay, so Pythagoras' theorem, we want to form a right-angled triangle, and the beauty of being on a Cartesian plane is that everything's nicely at right angles. We've got x and y axes at right angles, and coordinates of points that enable us to work out distances, vertical and horizontal distances. So that purple vertical distance, the rise, we're becoming quite familiar with that from talking about gradient previously, would be 5 minus 1, so that's a distance of 4. Okay, and the horizontal distance, or the run, would be the change in the x-coordinates, so 4 minus 2. Okay, so there's our triangle. So it suggests that we should use Pythagoras' theorem to calculate the length of a line segment. So we've got our right-angled triangle. We're trying to find the length of the hypotenuse. The hypotenuse is called AB. We know that the hypotenuse squared, so AB squared, is equal to the sum of the squares of the two other sides, 2 squared plus 4 squared. So that is 4 plus 16, which is 20, and so therefore AB is the square root of 20. And in our subsequent topic, our next topic after this, we are going to be looking at indices and surds and reviewing surds. So for now, I'll try to set questions in assessments where you perhaps don't need to simplify the surd. In this instance, the surd simplifies, so maybe let's do that and hope that things come back. So when we're trying to simplify a surd, we're looking for the largest square number that divides into 20, and that's going to be 4. 4 is the biggest square number that goes into 20, a square number being a number that you get by squaring another whole number. So 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, etc. So 4 is the biggest one that's going to go into 20. 20 is 4 times 5. And then the reason we were looking for square numbers that go into 20 is because we can now split the surd up. This is the square root of 4 times the square root of 5. And we know root 4 is 2, which is why we needed square numbers. And so this is 2 root 5. We don't have any units here, so it's a length, but just units. Okay, so what I want you to remember is finding the distance between 2 points is just an application of Pythagoras' theorem. If you find yourself stuck and you can't remember the formula, or you're not sure if you remember the formula correctly, use Pythagoras' theorem. In many instances, using Pythagoras' theorem is actually more efficient. By the time you've done a little rough plot of where the points are, you might actually realise that the situation is quite simple, and things then become very straightforward. Regardless, let's establish a formula. But as I said, I just want you to remember that all the formula is doing is using Pythagoras' theorem to find the length of hypotenuse. Okay, so we've got this point A and point B. A has coordinates of x1, y1, and B has coordinates of x2, y2. We've met that in the previous video when we talked about gradient. Remember that x2 doesn't mean x squared. We're just talking about the second x coordinate. Once again, like when we talked about with gradient, it doesn't matter which point. We could label B as x1, y1, x1, y1, and we could label A as x2, y2, and it would make absolutely no difference. Okay, so doesn't matter which way, which point is x is point 1 and which point is point 2. It's irrelevant. Okay, so we want to, now we're trying to create a formula. So we've thought about a specific example, how we use Pythagoras there to find the distance between those 2 points, or the length of the line segment. And now we're going to generalize that by finding the length of this line segment where we don't actually know the coordinates. Okay. Alright, so we make a right-angled triangle. We want to be able to describe the vertical height of that triangle, which is essentially the rise. We've talked about this with gradient before. So that's the difference between the y values, y2 minus y1. And then the bottom of the triangle, the green length, the run, is the difference between the x values, so x2 minus x1. Okay. So if we think about using Pythagoras' theorem, we're trying to find the length of the hypotenuse, which is AB all squared, is equal to the sum of the other two sides squared. So it's going to be y2 minus y1 all squared plus x2 minus x1 all squared. Okay, so let's talk about this. Would it make any difference if I wrote x2 minus x1 first and then squared that and then added on y2 minus y1 all squared? No, it wouldn't, because adding is commutative. We can swap the order of addition, so that wouldn't make any difference. The other thing that wouldn't matter here is if we did this subtraction the other way around, because let's just have a look at some numbers for a minute. If you do, let me get some, 5 minus 3 all squared, that is 2 squared, which is 4. If you swap those two numbers around and write 3 minus 5 all squared, you get negative 2 all squared, but because you're squaring it, it doesn't matter whether it's negative or positive, you're still going to get the same value. So it wouldn't matter if you reversed the y2 and y1. And so when we do gradient, and it really matters that if we're going to, if we have 2 points, let's go with the ones we had above. So if we have those 2 points, 2, 5 and 4, 1, when we did gradient, remember it's change in y, so 5 minus 1 over change in x, 2 minus 4. We have to make sure the points match up, okay? So we get 4 over negative 2, which is negative 2. Or we could have done it as 1 minus 5 over 4 minus 2, which would have been negative 4 over positive 2, and still negative 2, okay? But the important thing is making sure that you use the points in a consistent order. Okay, so if you do y2 minus y1 on the numerator, you have to do x2 minus x1. But if you did y1 minus y2 on the numerator, you would have to do x1 minus x2 on the denominator. The difference here is this formula is a lot more flexible on that front, okay, because it doesn't really matter whether you flip around. So actually it wouldn't matter if we had these around the other way and these this way around, because we're squaring them, we're still going to get the same result anyway. Now, students get really muddled up here because you've got squareds and you've got subscripts, which are ugly. You're also subtracting in the brackets but adding outside, and people muddle that up. And so once again, I want you to be able to come back to what the formula is doing. It's Pythagoras' theorem. Okay, so you're taking the rise, squaring it, so that's the difference in the y value squared, the run, which is the difference between the x values squared, and you're using Pythagoras, which means you square each of those things and you add them. Okay, so come back to Pythagoras if you get stuck. Our formula is not quite complete yet because we want to get a formula for AB. So to actually find AB, we would be taking the square root of all of that. Okay, so there's our formula. So the length of the line segment AB, where A is x1, y1 and B is x2, y2, is going to be this. y2 minus y1 all squared plus x2 minus x1 all squared. Or just use Pythagoras. Draw a diagram, draw out a triangle, and use Pythagoras if you can't remember the formula. Okay. Alright, let's have a look at some examples. Find the length of the line segment AB, where A is negative 2, 3, and B is negative 4, negative 3. Now I'm going to use the formula here because I've got it here. I know it, but once again, draw out a little diagram and use Pythagoras' theorem. So AB is going to be the square root of difference between the y values, 3 minus 3, all squared, plus the difference between the x values, negative 2 minus negative 4, all squared. Okay, so let's work out what we've got there. 3 minus 3 is 3 plus 3, so that's 6 squared, plus negative 2 minus 4 is negative 2 plus 4, which is positive 2, so 2 squared. Now, once again, if you had done those subtractions in the reverse, this line would be negative 6 squared plus negative 2 squared, and it's still going to give you the same thing. Okay? If you'd done one of them in reverse, you would have had positive 6, so if we had done just this one in reverse, we would have still had positive 6 squared, but negative 2 squared, but you still would have got the same answer. So it doesn't really matter which way around you do those subtractions. But equally, I would encourage you to try and still maintain that consistency, that this point is the same as this point, or from the same coordinates, and this is from the same coordinates as this, just so that you're developing that habit that then means when it does matter, for example in the gradient formula, that you're used to being a bit consistent about how you use the points. Okay, so 6 squared is 36, 2 squared is 4, and so we have the square root of 40. And once again, that's a surd that will simplify. We're looking for the largest square number that goes into 40. 4 definitely goes into 40. 9, 16, 25, 36, none of those go into 40, so 4 is the biggest one. 4 times 10, which means it is root 4 times root 10, so simplifies to 2 root 10 units. Okay. Find the distance between the points. So before we move on, let's just have a quick, let's just show how that would work if we, I'm just trying to think through where those points are. So if you have sort of, negative 2, 3 and negative 4, negative 3, think about drawing your triangle. This is going to be 2, this is going to be 6, so hypotenuse squared equals 2 squared plus 6 squared, which is exactly what we're seeing there. Okay, so when in doubt, a rough plot and draw the triangle. Part 2, find the distance between the points A and B. Okay, this is where I really want to encourage you to stop and think a moment before you launch into calculations, because there's something really important about these 2 points. Okay, and what's really important about those 2 points is that they have the same y-coordinate. So actually, whilst the formula will absolutely work, it's a very long-winded, difficult way to go about finding a very, very simple length. If you think about what you've got happening here, you've got a point at 1, 4, and you've got another point at negative 2, 4, and so there is no rise, it's just a horizontal distance. It's just going from negative 2 up to 1. It's just a distance of 3. Okay, so stop and think a little bit before you make life harder for yourself than it needs to be. Okay, so it's a length of 3 units from A to B. Okay, question 3, we're going to work a bit in reverse. So if the line segment joining these 2 points where we have an unknown y value, if that line segment has length 5, find the value of A. Okay, so if we call that point A and that point B, to find the length of AB, we would be calculating the square root of, now it's going to be nicer if I've got my A at the beginning, so I'm going to do A minus 2, just in terms of the equation I end up with, plus negative 1 minus 3, all squared. Okay, so this is the square root of, that's A plus 2, all squared, and that's going to be negative 4, all squared. So A plus 2 all squared plus 16, okay. Now, we know that the length of AB is 5, okay. So the length is 5, so 5 equals that. And now we have an equation to solve. We can solve the equation to find what A is, okay. So it's simply about rearranging, doing the same thing to both sides until we get A on its own. So thinking about how the right-hand side of the equation has been built up, we have a sitting here, we're adding 2 onto it, then it gets squared, then we add on 16, then we square root it, okay? So if you're thinking that through, start with a, you've added 2, it's been squared, you've added 16, and then you've square rooted. So to solve, we need to work our way back using inverse operations. So the opposite of square rooting is to square both sides. So when we square both sides, we're going to get 25 on the left, and squaring the right-hand side gets rid of the square root. Then we need to undo the add 16, which is to take away 16 from both sides. So we're going to subtract 16 from both sides. 25 minus 16 is 9. Then we need to undo the squaring, and the opposite of squaring is to square root both sides. Now, when we take the square root, remember we get plus or minus. So if a plus 2 all squared equals positive 9, that means that a plus 2 could be positive 3, but it could also be negative 3. Okay, so when we take the square root, we get positive or negative 3 equals a plus 2. And then the last thing we need to do is undo the plus 2, which is to take away 2 from both sides. And so a is going to be equal to, now, it is plus or minus 3 take away 2. Actually, I'll leave it like that. And we don't stop there. That's 2 different numbers, because plus or minus 3 is 2 different numbers. So we want to work out we've got negative 3 take away 2, which is negative 5. Or we've got positive 3 take away 2, which is positive 1. So we've actually found that there are 2 values of a that make this true. Let's just have a little think about what's happening here. So we've got the point 3, negative 2, and negative 1a. So negative 1, 1, 2, 3, 1, 2, 3, negative 2 is here. Okay, we need further down there. And we know that the other point, point A, so this is point B, point A is somewhere on this line because we know that it has an x-coordinate of negative 1. And we know that the length from B to A is 5. So what we've found is that it could be the point negative 1, 1. That was one of the solutions. That length there will be 5 apparently. But if we imagine swinging this line around like a pendulum, there will be another point down here, and it happens to be our other solution was negative 5. So this is the point negative 1, negative 5, where this distance is also 5. So there are in fact 2 answers, 2 points that will fit this information, that will be 5 units away from here. Okay. Alright, let's have a chat about the midpoint. So midpoint, a line segment joins 2 points, A with coordinates of 1, 2, 1, 2, and B with coordinates of 5, 8. Put that up there, so let's say B is 5, 8, and A is 1, 2. Okay. And so we want to plot the line segment on the axis below and consider how one might determine the coordinates of the midpoint. Okay. So we want the midpoint, and sometimes people get bogged down in thinking about midpoint, oh it's halfway, so we work out the distance and we halve the distance. But the midpoint isn't about what's the halfway distance, the midpoint is about what is the location of the midpoint. Okay, so we want to know what are the coordinates of the midpoint. So what we actually want to be able to think about is if we were to think about, you know, these 2 triangles here, okay, we know that that length is the same as that length if M is indeed the midpoint. Okay. Now, the other thing that we know is that these 2 triangles, they're both right-angled triangles, they both have the same angle here because those are corresponding angles. They both have the same angle here, again, because those are corresponding angles. And so what we have here is 2 congruent triangles. Now, we haven't done any of this year, but perhaps you remember some of that from last year or previous year. Congruent triangles are 2 triangles that are exactly the same. So that means that this length along the bottom here is the same as this length along the bottom here, and that this length up here is the same as this length up here. So they're exactly the same triangle. Now, if we think about what's happening here, we've got, that is our run, if you like, from A to B, okay? And then we know that the x-coordinate of point M is going to be exactly halfway between that, because we know that the two distances have to be equal. The base of those two little triangles has to be equal. The same thing is true for the rise. Okay, so from B to A, okay, we know that the coordinates of the y-coordinate of the midpoint will be halfway between the two other y-coordinates. Okay, so if this is 2 and this is 8, halfway between 2 and 8, we can see, because we've got a nice graph, is 5. This is 1 and this is 5. Halfway between 1 and 5 is 3. And so the midpoint is going to have coordinates of 3, 5. Okay, and this point, the 3, is halfway between the x-coordinates of the other 2 points, and this point is halfway between the y-coordinates. So a more general question for when we come to generalizing in the next part is, okay, well, how do we find halfway between two numbers? These were nice, easy whole numbers. They weren't very big. We could see that halfway between them was 1 and 3. But mathematically, how can we work out halfway between them? Okay, and the answer to that is halfway between two numbers is the average of those two numbers. So if we had added together 5 and 1 and divided by 2, we would have got 3. Similarly here, if we had added together the two numbers 8 and 2 and divided by 2, we would have got 5. Okay, and so halfway between the x-coordinates is the average of the x-coordinates. Okay, and halfway between the y-coordinates is the average of the y-coordinates. So that's all we need to remember. Once again, this is a question that I find students, all through year 10, 11, 12, say, oh, what's the formula for midpoint again? Forget the formula. It's average of the x-coordinates and the average of the y-coordinates. So if we were to generalize that here, finding the midpoint would be the average x-coordinates and the average y-coordinates, which means that it's going to be, you add together the two x-coordinates and you divide them by 2. And you add together, the two y-coordinates and you divide them by 2. Now once again, people get confused. Oh, do I add them or do I subtract them? Remember that you're averaging them. You're finding halfway. Okay? Does it matter, do I do x2 plus y1 or the other way around? It's the same. You're adding them. It doesn't matter what order you add them in. Okay? So you're averaging the x-coordinates to find the x-coordinate of the midpoint, and you're averaging the y-coordinates to find the y-coordinate of the midpoint. That's all you need to remember. Yes, there's a formula, but understand what the formula is doing so that you can remember it. Okay, example 1. Find the coordinates of the midpoint, M, of the line segment AB, where A and B have coordinates of those things respectively. Okay, so our midpoint is going to be the average of the x-coordinates for its x-coordinate. So we're going to add together the two x-coordinates and divide them by 2, and the average of the y-coordinates for its y-coordinate. So negative 2 plus 3 is positive 1, so that's 1 over 2. 6 minus 7 is negative 1, so it's negative 1 over 2. And so that is the coordinates of the midpoint. In question 2, we want to work backwards. So if this is the midpoint, okay, so that is M, and it's the midpoint of AB, and we're told what A is, okay, but we don't know what B is, okay. So let's let B just be XY, or AB, or whatever you want to call it. It doesn't really matter, okay. So we know that the midpoint is going to be the average of the x-coordinates, so that'll be x plus 4 divided by 2, and the average of the y-coordinates, so that'll be y plus 7 divided by 2, and we know that that midpoint is 3 on 2, negative 2. So that means that x plus 4 divided by 2 must equal 3 on 2. That's going to enable us to find what x is. Okay. So multiplying both sides by 2, x plus 4 equals 3, and subtracting 4 from both sides, x must be negative 1. Similarly, the y-coordinate, y plus 7 over 2, has to equal negative 2, So y plus 7 over 2 equals negative 2. Let's multiply both sides by 2, so y plus 7 equals negative 4. And subtract 7 from both sides, so y equals negative 11. And so therefore, the coordinates of B are negative 1, negative 11. And that will ensure that the midpoint of AB does indeed have coordinates of 3 on 2, negative 2. Okay, the work today is a mixture of questions from exercise 1H. These two videos that are linked here are to some much older videos on midpoint and distance between 2 points, so if you feel you need another explanation, you can go and access those videos.